Okay, good afternoon, chemistry class. This is Coach Jeans, and today we're going to look at ionic and net ionic equation. I know you're excited. You can't wait to get started with this. So grab your composition notebook. Probably want your periodic table out as well as we talk about this. Now, most reactions in chemistry happen in solution. They happen with aqueous compounds. And so a net ionic equation can show us exactly what's going on, which ions are involved, and which ions form the correct products that we're looking for. So these are very helpful and useful to show what's actually going on in the equation. Now understand something. When an ionic compound that is a solid is placed in water, most of them, because they're ionic, will dissolve in water. So for example, something like sodium chloride. Sodium chloride obviously dissolves in water. And so if you look at this graph here, you can kind of see how if you have solid sodium chloride, you've got your sodium ions and your chloride ions, everything's packed in there together. You place that in water, maybe stir it up or whatever, and the water molecules are able to be attracted to the positive sodiums and the negative chlorides, and they're able to break them apart. This process is the dissolving process, and when this happens, we call it dissociation, or we could also call it ionization. Because what happens if you could look and you could see the actual atoms or the ions, you could see some positive sodium ions floating around and some negative chloride ions floating around in solution. And so many salts will completely ionize, some will only partially ionize. But we're going to kind of consider these, and we will take a look at net ionic equations here. Now, when you write net ionic equations, you're always going to follow a certain set of rules, and I'm going to give you these rules, and you're going to need to be able to follow these as we write these down. And of course, we'll do plenty of examples. So pause the video as needed here, and you want to copy these rules down for writing net ionic equations. There's going to be 3 of them. Okay, number 1, you're going to write the balanced chemical equation first. You must always start out with a correctly written equation that has the correct formulas. Now, again, let me emphasize to you that you must have the formulas correct. The subscripts must be written based upon what ions they're bonding with, and so that the overall charge, it must equal out to 0. So all your positives must equal zeros, and so therefore you have the correct ratio. So don't forget how to write chemical formulas. Write that first. Then once you have it into the formulas, then go back and balance the chemical equation by placing in the correct number of subscripts. We've done plenty of examples of this. In the last class, we did double replacement reactions. We should have had plenty of help with balancing these, plenty of practice with that. But if you need some more help, by all means, get some help. Come and see me or check some things out on the internet. So when you write a balanced chemical equation, again, do the reaction products, figure out what's going on, swap your cations and your anions to form your new compounds. Be sure to check your charges and write the correct subscripts. Then you want to predict the solubility. Again, in a double replacement reaction, both of the reactants must be aqueous, and one of the products must be insoluble. So both reactions must be soluble. One of the products must be insoluble. So that means it either is going to form a solid or a liquid or a gas. And if it doesn't, then that reaction won't happen, and you can't write a ionic equation for that. All right, number 2. You want to write the complete ionic equation next. Again, I'm going to show you some examples of that. If the compound is a solid, if one of the products there is a solid, then that compound does not ionize in solution. It is going to be a precipitate. And so that means it forms a solid. So we're not going to break that up. We're going to write it down in its compound form. We're going to write the formula for that. If it is an aqueous, AQ, then the compounds do ionize. So they break apart into their ions. Now look at the note here. When you take a compound and you convert it over to the ions, the ion subscripts in the formulas become coefficients in a complete ionic equation. And I'm going to show you some examples of what I'm talking about here. All right, copy down number 3. And number 3, you're going to write the net ionic equation next. When you do this, or how you're going to do this, is by canceling your spectator ions. What are spectator ions? These are ions that do not really get involved with the reaction. And so the way you know they're spectator ions is that they'll appear on both sides of the equation. And so what you do is you cancel these out, sort of like when we cancel things out in math. And whatever cancels out, those are spectator ions. And then whatever is left that didn't get canceled out, you rewrite those, and that becomes your net ionic equation. Your net ionic equation basically is your simplified form of what we call a complete ionic equation. So the best way to do this is by jotting down some examples. So we'll switch over to this screen and help you learn how to do this by looking at a few of these examples here. So again, you want to check your solubility of these examples. Make sure you have your solubility table handy, or at least that you remember your solubility rules on this. So the first reaction we're going to do is barium nitrate, and nitrates are always aqueous, so be sure to check that. And nickel sulfate, okay, which is also an aqueous solution. And then what you're going to do is you're going to predict the product. So you look at this, you say, okay, that's one of those double replacement reactions. So the way I recommend doing that is, again, use that little scratch pad method. Take your ions, barium is Ba, write the charge, 2 plus. All right, nitrate is NO3, 1 negative. Nickel, okay? Well, nickel's a transition metal. It's bonded with sulfate. Well, sulfate is SO4, 2 negative. So therefore, since there's just one nickel, it has to be a 2 positive. And then what do? Again, you just crisscross and you switch your cations and your anions. So barium is going to bond with nitrate to form BaSO4. Leave a little space to put your state symbol, plus nickel, and it's nickel 2 nitrate. So we need to have it NO3 and in parentheses with a 2 on the outside. Then we need to make sure that we go back and we balance this. So check and see that it is balanced. Here we have one barium. We have 2 nitrates, and here we have 2 nitrates. Nickel, we have 1 and 1. Sulfate, we have 1 and 1. So it's okay and it's balanced. Now, next we need to also make sure that we check our solubility. Barium sulfate, when you check it, it would be insoluble. So if it's insoluble, we put an S beside it. That means it is a solid. And then nickel nitrate is aqueous. All nitrates are always aqueous. So that means they are soluble. They dissolve in the solution. Okay. So now we have it in a balanced chemical equation. Everything is good. Now what I want to do is go back, and every formula that is aqueous is going to disassociate. It's going to break down into its ions. So this is step number 1 right here. Now let's go to step number 2. Barium nitrate. Well, we're going to say Ba, and this time we're going to put the charge with it, 2 plus. We're going to break this up. So we're going to say plus nitrate, NO3, but notice I have 2 of them. So this subscript becomes a coefficient. You say, well, why this one? Well, remember, nitrate is an ion, so we need to make sure we put our charge with it as well. So therefore, we have 2 nitrates. Well, then we have nickel sulfate, which is also aqueous, so we put our plus sign. We have nickel, which is Ni. It's a 2 plus charge. Then we have plus sulfate, polyion. It's a 2 negative charge. All right, so we come to our arrow. So we're going to draw our arrow next, just like we did before. Now we have barium sulfate. Notice that barium sulfate is a solid. Solids do not ionize. So I'm simply going to copy the formula down. I'm not going to break it apart. It is the formula barium sulfate. Next, we're going to have plus nickel. Nitrate ionizes, so we're going to break it up. Nickel 2 plus my nitrates, and that's going to be 2 of them, again, because I have a subscript of a 2 right here, so that becomes the coefficient to show me that I have 2 nitrates. Okay, so it's kind of like working the opposite way there. Now that what we have there in line number 2 is called the complete ionic equation. It shows all the ions, and we do need to come back and place an S right there just to show that that is a solid. We don't need to put any state symbols with the ions. Obviously, they are in ion form, so they are disassociated and they are in solution. Now what we need to do is we need to go and look and say, okay, what ions do I have on both sides of the equation? Okay, so we're going to write what's called the net ionic equation. So I look here, I have a barium 2 plus, but I don't have a barium 2 plus on the right side. I have 2 NO3 and I have 2 NO3. So these, we're just going to run a line through them. We don't scratch them out or anything, and just cancel them out, just sort of like you cancel out when you do things in math, like factoring. So we have 2 nitrates cancel with 2 nitrates. We have a nickel 2 and a nickel 2, so we're going to cancel those out. And then we have a sulfate, and notice that there's nothing for it to cancel out on the right-hand side. So now what I do is I rewrite it, and I only include the ions that did not cancel. So I'm going to have Ba, 2 plus my next one is SO4, 2 negative, okay? And then the arrow forms our formula for barium sulfate and then put the solid beside it. And so this line number 3 here would be called your net ionic equation. All right. So I know it looks like it's complicated, but if you just take it step by step and do it like I explained in the rules, follow these examples, then you'll be fine. Okay. So let's take a look at another one. All right, we'll separate that out. And what we're going to do, let me get that straight. We're going to do lead nitrate. All right, this is lead 2 nitrate plus sodium iodate, or iodide, sodium iodide. Okay. Now, nitrates are always aqueous. All right, we check our solubility, and sodium, group 1 element, and forms with a halogen, so that is going to be aqueous as well. Okay. Now, what's going to form? Well, again, this is a double replacement reaction, so we're going to draw our little scratch pad again. I encourage you to do this every time. We're going to have Pb 2 plus. You say, how'd you know that? Well, remember nitrate. Nitrate is NO3 1 negative, and so since there's 2 of those in our formula, then that means that this lead had to be a 2 plus. Sodium is Na. We just check the periodic table. We know it's 1 plus. Iodide is 1 negative. So we're going to cross over and switch over our cations and anions. So now what we're going to write? We're going to write sodium nitrate. Okay, sodium's positive 1, nitrate's negative 1. Okay, it's a nitrate, so it's aqueous. Plus what? Lead, Pb, I2, and we check our solubility on that one, and we see that this would be our solid. This says it's insoluble, so that means it forms a solid, a precipitate. All right, now what do we need to do next? Well, we need to make sure that we balance the chemical equation. And so I look at this one, and I say, well, I've got 2 nitrates over here on the left-hand side, 2 nitrates. So I need 2 over there. So place a 2 in front of that. They give me my 2 nitrates. Well, that changes my sodium, so I need to place a 2 there, and that means I've got 2 iodides and 2 iodides. So now it is correctly written. Now what I want to do is go and write the complete ionic equation. So this is the balanced chemical equation. Now I'm going to write the complete ionic equation. Right? So let's take a look at the complete ionic equation. Everything that's aqueous gets broken down into ions. So we're going to have Pb, it is a 2 plus 2 nitrates, okay, plus 2 sodiums, plus 2 iodide. Now, why did you say, well, remember this 2 goes with everything that's in front of. So that means we have 2 sodium ions, we have 2 iodide ions. Now we go over here to the right-hand side. We have sodium nitrate, so we have 2 of them, Na plus 2 nitrates. Again, this 2 goes with it, plus what? Pb, I2, and that one is aqueous. So that's your complete ionic equation. Now let's take the complete ionic equation and write the net ionic equation, all right? What we want to do is we want to figure out what are the spectator ions. The spectator ions are those that are on both sides of the equation. So we can cancel those out. We have a lead 2 plus here, but we don't have it over here. We have 2 nitrates and 2 nitrates. So we're going to cancel the 2 nitrates out. We have 2 sodiums and 2 sodiums. So that cancels out. And we only have 2 iodides left over. We don't have anything on the right. So now we just copy it over by placing what is left, what did not get canceled. So we have Pb 2 plus 2 I negative forms Pb I2, and we put our state symbol of a solid in there. All right. Let's take a look at another example here. Let's do sodium chromate. So we have Na2CrO4. That's aqueous. Sodium chromate is aqueous, plus silver nitrate, AgNO3. That is also aqueous. And then we're going to leave it like that because I want you to be able to predict what the products are. So again, what are we going to do? We're going to use our little scratch pad over here, right? And in our little scratch pad, we're going to write down the ions. So we're going to put Na plus and CrO4 2 negative, Ag plus and NO3 negative. And then our cations switch places. So what are we going to have? We're going to have sodium nitrate, NaNO3. It is aqueous, plus silver chromate, AgCrO4, and we need to make sure that's a 2 right there. So Ag2CrO4. We check our solubility on that one, and it is a precipitate. It is insoluble, so it is a solid. Then we need to balance this, so we can balance it. Let's see, we need to place a 2 right there and a 2 right there, and now it is correctly balanced. Now let's take all of our aqueous and place them into ions. So here we're going to have 2 Na plus CrO4. Okay, that's a 2 negative. Well, let me write it like that. 2 negative plus 2 Ag plus 2 nitrates. All right, forms 2 sodium ions plus 2 nitrate ions. Okay, I'm going to put it down here, plus Ag2CrO4 solid. Okay. Now we're going to go back and cancel out all of our spectator ions. So I have 2 sodium ions and 2 sodium ions. I have 2 nitrate ions and 2 nitrate ions. These will not precipitate out, so I'm going to rewrite it. CrO4, 2 negative. Again, let me write it like this. 2 negative plus 2 Ag plus. And what does that form? That forms Ag2CrO4 solid. All right. Let me flip the page. We'll do one more, okay? It's good to see these examples and have plenty of things to work off of. So let's do hydrochloric acid, which is going to be HCl, okay? It's aqueous, plus sodium hydroxide. So this is a neutralization reaction. That's also aqueous. Well, we treat neutralization reactions just like we do double replacement reactions, all right? So, whoops, let me go this way. So draw your little scratch pad, and you're going to put your H positive, Cl negative, Na positive, OH negative. So again, these are going to switch places, and you're going to form sodium chloride, that is aqueous, and you're going to form HOH, okay, which you could also write down as what? That could be written down as just plain H2O, okay? So you could write it like that, which would be fine, which most of the time that's what you're going to see. You got HOH, hydrogen hydroxide. Well, that is water. And water at room temperature is what state? Yep, it's a liquid. So we're going to put a little L beside that one. So remember our condition is that one of the products had to be insoluble. That means it had to be a solid, liquid, or gas. And so this one forms a liquid. So this reaction does happen. So now we're going to take all our aqueous and we're going to convert them into ions. So we're going to have H plus Cl negative plus Na plus, positive that is, plus OH negative. All right, then we're going to have forms Na positive plus Cl negative plus H2O liquid. Okay, I usually use a little or a cursive L just so it doesn't look like a 1 right there when I do liquids when I'm writing them out. All right, now we're going to take and convert it over to the net ionic equation. So our chlorides are going to cancel out, our sodiums are going to cancel out, and so we're going to have H positive plus OH negative forms H2O liquid. All right, and that's it. This is called an acid-base reaction. And essentially what happens in an acid-base reaction, when you have enough acid and base, they completely neutralize each other. And what you get is you get salt water. And that's a neutralization reaction. All right, we'll look at a lot more examples in class, go over any questions that you have. And so I hope you understand this. If you're having any problems, re-watch the video. Make sure you're taking notes. and I look forward to seeing you next time in class.